Good morning, class. Welcome to my instructional video on derivatives. So in this standard, remember we're talking about the rules that you need to know: power rule, product rule, and quotient rule. Yesterday we went over the product and power rule, which were shortcuts to that super long derivative one that we don't like. So I'm going to go over a quotient rule today, and also this concept about a tangent line and a normal line. For those of you that may have forgotten what that means, let me just draw, you don't have to put this in your notes, let me just draw a random curve. So here's my axes, and I draw a curve like this. Okay, just a random one. And someone says, hey, awesome person, draw a tangent line. So what if I pick a point here? Just say draw a tangent line to that point right there. The definition of a tangent line is a line that essentially, and I'm a terrible drawer here, but touches the curve, or whatever graph you choose, just at that point. And the also unique property about a tangent line is that it has the exact same slope at that point. So this straight line right here and this curved line here have the exact same slope here. That's the definition of a tangent line. And since we know the shortcut for derivatives, it should be very simple for us to figure out how to find a tangent line. And some of you may have forgot that from last year, and we'll review it today. And you'll always see it on the AP exam. So I'm going to scroll down, but you're going to go over to the next page. This part right here, where it says the product rule for 3 functions, you do not need to do that. So that's also something that you could just cross out. Let me scroll down, and you could turn the page. Something that you need to know. Proving the derivative. So we came up with the product rule, and if you forgot the product rule, my favorite way of remembering it is derivative of the first one, leave the second one alone, plus leave the first one alone, times the derivative of the second one. Okay. So this question says, oh, well, that's nice and dandy, but can you prove that this actually does find a derivative? So this question, and something that you might see on the AP exam, is prove both through the power rule and the product rule that the derivative is the same. So let's do the product rule first. Product rule is a little bit simpler. So I'll take the derivative of the first one. The derivative of this one is 4x to the third, and the negative 5 cancels, and I'll leave the second one alone. Then I'll add. I'll leave the first one alone, times the derivative of the second one. And the second one here is going to be 2x minus 4. So that is a derivative using the power rule. Okay. To make things a little bit more neat, I'm going to simplify by distributing all of these. So this one, I have one term multiplied by a whole term. So if you remember doing the distributive property, I'm going to multiply this across all 3 terms. So this is 4x to the 5th by adding the exponents. This will be minus 16x to the 4th. And this will be 8x to the 3rd. Over here, I have 2 parentheses. I have this times this. So that tells me I'm going to have to use, can't just like distribute. I'm going to have to do FOIL. So 3x to the 4th times 2x, that's 6x to the 5th. 3x to the 4th times minus 4, that's minus 12x to the 4th. Minus 5 times 2x is minus 10x. And minus 5 times minus 4 is plus 20. Now I'll simplify by combining like terms. The highest exponent I have is to the 5th power. So this becomes 10x to the 5th. Oh, sorry, yeah, 10x to the 5th. I have negative 16x to the 4th minus 12x to the 4th. If I combine those, I get minus 28x to the 4th. To the 3rd power, I have 8x to the 3rd. I don't have anything to the 2nd power. And then I have this minus 10x plus 20. And that is the derivative using the product rule. Any questions? So if you want to copy this down, maybe you want to pause the video or whatever. I'm going to erase this all and try to do the same thing. Actually, you know what? I'll just do it down here to make sure I have the correct answer using the power rule. So this one is product rule. I'll just write prod. Now let's do this during the power rule. Using the power rule, what I'm going to do is I'm going to distribute this first. Okay. So 2 ways to solve this. You could do product rule, you could do power rule. Remember yesterday in class I said, sometimes it's easier to do one rule over the other. depending on this one, it could be one or the other. So let me multiply this out first. If I multiply this out first, okay, 3x to the 4th times x squared is 3x to the 6th. 3x to the 4th times minus 4x is minus 12x to the 5th. I got 3x to the 4th times 2, which is 6x to the 4th. Oh no, it's doing that crazy zoom thing again. 6x to the 4th. Alright. Now, I'm going to multiply the, oops. Oh, erase everything. Alright, let me write this out real quick. 3x to the 6 minus 12x to the 5th plus 6x to the 4th. And then minus 5x squared plus 20x minus 10. Now I will use, all I did was multiply this out, right? So now I gotta do now I gotta actually do the power rule. Okay, so let me just check my work. 3x to the 6 minus 12x to the 5th plus 6x to the 4th minus 5x squared plus 20x minus 10. Now I will do the product rule. So what it is, again, is if you forgot, multiply these two. I get 18x to the 5th and subtracted 1. I'll multiply these two and subtract 2. I get minus 60x to the 4th. Multiply these two, I get 24 and subtract 1, so 24x to the 3rd minus 10x, and plus, the derivative here is just plus 20. And I wish I didn't erase all that stuff, but hopefully this matches what I did with the product rule. I think it is. So essentially, I proved that the power rule and the product rule both give me the same answer, and that's something that they expect of you from the AP exam. Now, here on the bottom, going on to the next problem. Oops. Going on to the next problem. It says here, find the equation of tangent normal lines. And this is what I was talking about at the beginning. Like if I had a graph and I wanted to make a line that was normal to it, tangent or normal to it, remember I draw a line to the curve. So again, there are going to be some things in calculus like, oh, who cares, or why are we doing this? Not entirely sure, but it's something that is a calculus standard if you want to pass the AP exam. So here's a function, right? 3x squared minus x sine x. Don't know how it looks like. I want a tangent line to it, okay? To find a tangent line, or anytime they ask for an equation of a line, so notice this. They ask for the equation of a line. Anytime they ask for that, in this class you're going to use a point slope form. And I'm not too sure how much you guys did of it last year. The point slope form is y minus y1 equals m x minus x1. In point slope form, this y and this x just stay y and x. And this y1 and x1 represent a point on the line. M represents slope. So as long as you have a point on the line, which is y1 and x1, as long as you have slope, which is m, you found the equation of a line. You don't have to do, I know in Algebra 1 we emphasize a lot of y equals mx plus b, but as long as you fill in y1, as long as you fill in m, and as long as you fill in x1, you have the equation of a line. So the very first thing is like, hey, look, they gave us x. So this right here, I've already solved, becomes x minus pi. Question is, what's m and what's y1? To find y1, all you do is plug the x, right here, into the original equation to find y. Remember, that's the definition of an equation or a function. I plug in an x and I get a y. So let's plug pi in here. I get 3 pi squared minus pi, parentheses, sine of pi. 3 pi squared minus pi, this cannot be simplified, and it's multiplied times sine pi. And some of you, I know we keep saying we're going to go back to this, or you can put it into your calculator. Sine of pi is actually 0. So 3 pi squared minus pi times 0 is also just 0. Okay. So this part is already filled out also, y minus 0. Now I only need one last piece to figure out what is the what's the tangent line, or the equation of a tangent line. M. M stands for slope, and as if I taught you at the beginning of this lesson, slope means the exact same thing as derivative. So I need to find a derivative of this function and plug in my x, and that'll give me the slope at that point. So let's take the derivative of this. You may notice that I have two things multiplied. I can't use power rule on this one. I can't multiply this out, but what I can do is the product rule. I'll take the derivative of the first one, which is 6x minus 1, and I'll leave the second one alone, sine pi, or sine x, sorry. Plus, I'll leave the first one alone, 3x squared minus x, times the derivative of the second one. Hope you guys remember the derivative of sine, which is cosine x. Alright, I've taken the derivative now, and now to figure out m, I'm going to plug in pi to see what I get. So I plug in pi, 6 pi minus 1, sine pi, plus 3 pi squared minus pi cosine pi. Alright, now let's simplify this out. If you remember from the last thing that we did, sine pi is 0. So 6 pi minus 1 times 0, this whole thing just becomes 0. However, on this one, cosine pi is actually 1. So 3 pi squared minus pi, that just stays as it is. Times 1 is just 3 pi squared minus pi. So the slope at pi of this function is 3 pi squared minus pi. So that is the slope. And it's not very pretty, but the slope, just to save time, the equation of the this goes in there. So the equation of the line is y equals 3 pi squared minus pi. I know my handwriting is getting crazier now. And then x minus pi. This is the equation of a line that is tangent. And we'll go over normal lines another time. Okay. So we're going to skip over this next one. So skip over this little example here, and let's go on to the quotient rule. Quotient rule, very similar to product rule in that the structure of the top is very similar. Derivative of the first one, leave the second one alone. Minus, leave the first one alone, times the derivative of the second one. Two big differences between quotient and product rule, if you remember from last year. There's now a minus in the middle, and it's all over the second, or the denominator squared. Okay, so let's look at this one. Says find the derivative of each expression. This one I got a trinomial at the top, I have a binomial on the bottom. I'm dividing them, so I have to use the quotient rule. Quotient rule says take the derivative of the first one, or take the derivative of the numerator, which in this case, let me do h prime x equals derivative of the first one, 3x squared plus 10x and that's it. Leave the second one alone, so x squared plus 4. Now, minus, which is new to this rule, leave the first one alone, x to the third plus 5x squared sorry, I know my handwriting is off, times the derivative of the second one, which is 2x. Okay, so far. And then you're going to do all over, so this big fraction bar, the denominator squared, which is x squared plus 4. And for the most part for quotient rule, even though this might drive some of you crazy, like, oh man, I need to simplify this, that is the answer. This is a derivative of this function, or I found the equation for slope for this function. Okay, let's try. I think you guys get the hang of it, so I'm going to try one step more difficult, which is below. So let's skip over this problem here and let's look at the question below. The reason why this is difficult, the reason why this is difficult, if you may notice, is that this isn't just a quotient rule. So some of you may look at this as like, oh, that's a quotient rule because I see a fraction bar there. That's got to be quotient rule. True, but when I take the derivative, when I start it, and I take the derivative of the first one, you're like, whoa, the derivative of the first one, that's a product rule, Mr. Salmingo. Well, yeah, you're right. That is a product rule. So this is a type of problem where while I do the quotient rule, I'm also going to do the product rule inside of it. Okay. So this is what I'm going to do. I'll start off f prime x, my ugly handwriting, f prime x equals the derivative of the first one. And the derivative of the first one, you may notice, is 2x to the third cosine x. So the derivative of the first one is a product rule. So here's the first one, here's the second one. The derivative of the first one is 6x squared. Leave the second one alone. I'll do plus, because this is product rule. Leave the first one alone, 2x to the third. And then the derivative of the second one, do you guys remember the derivative of cosine x? Yeah, negative sine x. And I don't know where my s went. Like so. So that's the product rule. I did the derivative of the first one. But I'm not even finished yet. All I did was the derivative of the first one, right? Now I leave, like if I put these in brackets, like all I did was the derivative of the first one. All I did was the derivative of the first one. I now leave the second one alone. This is quotient rule. Remember, this is a fractional bar. This is x squared minus 7 minus, leave the first one alone now. So the first one is 2x to the third cosine x times the derivative of the second one, or the denominator. And the derivative of x squared minus 7 is 2x. And this is quotient rule. So I'm going to make my big fractional bar all over, and this one's going to be x squared minus 7 squared. Again, some of you are saying like, man, this is so messy, or it's not simplified, but you just leave it like that. Okay. And the last example that I want to go for you guys today, it says here, find the equation, the tangent line, and the normal line. And I told you guys we're going to go over normal lines another day, but let's do a tangent line problem. All right. In this problem, when I look at the tangent line, I have sine x over 3x minus 5. Again, I want you to notice something. Anytime a question asks you for an equation of a line, you're using point slope form. In case you forgot, y minus y1, oops, y1 equals m parentheses x minus x1. And in point slope form, just as the form sounds like, all I want is a point, y1 and x1, and a slope, m. They always give you something first. In this case, they gave us pi over 3. So in this case, I will plug pi over 3 in here. Now I'm just missing two pieces, y1 and m. The easier one is y1. To find y1, I will do is plug pi over 3 into this problem. Okay. So what I'm going to do is I'm going to plug in pi over 3 into this problem. So let me just do a side calculation here. By plugging in pi over 3, I get sine of pi over 3. Actually, you know what? Let me just make it quick. Sine of pi over 3, you could use a calculator, or eventually you need to use the unit circle or memorize it. Sine of pi over 3 is 1/2. Sine pi over 3. Let me think about this. 1, 2, 3. Oh, sorry. Sine of pi over 3 is radical 3 over 2. Okay. And then plug in pi over 3 here. 3 times pi over 3 is just pi. And then minus 5. I've got a fraction within a fraction. Some of you may have forgotten. I could push this 2 sort of down and distribute it. So this means the exact same thing as radical 3. Radical 3 over 2 pi minus 10 by distributing that 2 up at the top. So now I figured out y1. It's ugly. It's not even like a nice number, but it is the y1 for this line. I don't know why my handwriting is like this. I'm sorry. Alright, now all I need is m. M stands for slope. Slope in calculus means the exact same as derivative. Alright, so I need to take the derivative of this. I have a fraction, so it tells you I have to do quotient rule. And I don't have any like products in there, not like that last problem, so this should be a little bit easier. So what I'm going to do is I'm going to take the derivative of the first one, and it's going to go in here, but I'm going to do another side calculation. Derivative of the first one is cosine x. Cosine x. Leave the second one alone. 3x minus 5. This is quotient rule, so I'm going to do a minus. I'll leave the first one alone. The first one here is sine x. And then I will do the derivative of the second one, and the derivative of the second one is just 3. And this is all over the denominator squared. In this case, it's 3x minus 5 squared. The last piece is I'm trying to find the slope at this point. I'm trying to find the slope at pi over 3. Is I need to plug pi over 3 into this whole equation. And so I'm supposed to get like a number or something because that's what I'm going to plug into this equation. If I plug pi over 3 into here, cosine of pi over 3 is 1/2. So I get 1/2. If I plug pi over 3 into 3x minus 5, I'm going to get pi minus 5. If I plug pi over 3 into sine, I'm going to get, again, radical 3 over 2. So here I'm going to get 3 radical 3 over 2. And some of you may be like lost already because of all these big numbers, but don't be intimidated. Just follow the rules. And on the bottom, when I plug in pi over 3, I'm going to get pi minus 5 squared. Again, your gut's going to say, man, this is so messy. Like, what is it? Like, I need to simplify this. Like, what do I do? It's an answer. It's an actual number. If I wanted to, I could put it inside calculator and get a number. But this is the slope of a tangent line to this function. Okay, so ultimately your answer is going to be y minus radical 3 over 2 pi minus 10. And then if I could just circle this, this is m, parentheses x minus pi over 3. That is the equation of a tangent line to this graph at this point. So we went over a lot very quickly. I told you, for calculus BC, so I need to pick up the pace. Also, this is just a review from last year. So if you're a little bit hesitant, I think you guys are comfortable with this. I wouldn't go fast if I didn't think you guys can get this pretty easily. So for the rest of the class, essentially, I'm gonna have you guys practice, and then Friday's lecture, you're gonna study the chain rule. So hope you enjoyed the video, and hopefully I'll see you soon. Take care.